In the previous video, I had forgotten, as I said, how to get the midpoint using the other way that I was telling you about, and we used this formula. So there's another question that I was working, and I had to get the coordinate of a point using the other way. So I remembered how to do it. So how do we find this point here, the coordinate of this point, not using the midpoint formula? Okay, so if we're saying that AB from A to B was 6 and minus 6, and if we're saying that M is the midpoint of AB, then A to M will be half midpoint of 6 and minus 6. So I was trying to do the right thing. I was dividing that by 2. This would end up being 3 and minus 3. So AM is 3 and minus 3. So how do we find the coordinate now? We know the point A is minus 2. Well, AM is M minus A, and AM, the vector, is equal to 3 and minus 3. So we know the coordinate of A. This is M minus, this was minus 2 and 8, and this is equal to 3 and minus 3. When we take that over, M, the coordinate, will be equal to 3 and minus 3 plus 2 and minus 2 and 8. And 3 plus minus 2 is 1, and 8 plus 1, and minus 3 plus 8 is 5. So that's where you get the midpoint, 1 and 5. So the vector OM is 1 and 5. So that's the other way. So that was one question I cleared up. And let's go to the final question we are going to solve in vectors. So the matrix T is such that T is equal to this. They want the inverse of T. So first we'll need the T inverse is equal to 1 over, yes, the inverse of T is 1 over the determinant of T equal to times T adjoint. So let's find the determinant of T. That is equal to AD minus BC, which is 3 times 2 minus 1 times minus 1, which is 6 minus minus 1, which is 7. A inverse T adjoint, the adjoint is changing the position of the elements in the leading diagonal, 3 and 2, and changing the signs of the elements in the non-leading diagonal. That'll be 1 and minus 1. Okay, so the inverse now will be T inverse is equal to 1 over 7 times 3, 1 minus 1 and 3, and 2. Good. Next question. Oh, this year is 2014. I think this is May 2014 or January. Please check the question. The next question is the matrix this matrix T, the matrix T, this one, maps the point A and B onto 9 and 4 and 9. Determine the value of A and B. I wonder if you guys notice that this is a simultaneous equation. The matrix T, what is T? 2 minus 1, 1 and 3 maps the point A and B onto the point 4 and 9. And that's simultaneous equation. So this is T. Let's call that X, and we can call that anything we want to call it. So now X is equal to T inverse A. And if you haven't noticed, we already found what T inverse is there. So it makes our calculations very simple. So A and B is equal to 1 over 7. This is 3, 1 minus 1 and 2 times 4 and 9. So how do we do matrix multiplication? 3 times 2, 1 over 7. I'm going down to the bottom here. 3 times 2, 3 times 4 plus 1 times 9, and minus 1 times 4 plus 2 times 9. So I'm coming up here. This is equal to 1 over 7. This is 3 fours are 12. And this is 1 times 9 plus 9. This is minus 4 plus 18. 1 over 7. This is 21 and 14. When a 7 comes in, 21 divided by 4, 14 divided by 7, 7, 7. This is 3 and 2. So A is equal to 3 and B is equal to 2. And this question was 3 marks, this one was 4. Okay, so this is a troublesome question. And let's see how best we can answer it. So the vector M, OM, and N, OM, and ON are position vectors with respect to the origin such that OM is equal to the common letter M. In vector geometry, we said that vectors are represented using variables. So like M is like our X and this NON is like a Y. Okay, just a variable. The next statement is L is a point on MN such that from M to L is 2 and from L to to N is 1. So ML and MN, is broken up into 3 pieces. Say M there, N there, right? From M to L is 2 and from L to N is 1. That's what how you read the ratio thingy. So here we go. Draw a sketch of triangle OMN and label the O and the M and the L. So I'm going to draw a little Cartesian plane here because they mentioned that these things are position vectors. Okay, so if I draw O to M like this, that can be M. Now, one of the things I would advise you to do is to read the entire question before you start working the question. So you read from A, part B, part C, and so on, so you can work the question. And why would we read the entire question and then go back to the top? Because there could be some information at the bottom of the question that is important for the top. And let me show you why that. See, this vector OM is 6 and 3 and 6, and ON is 9 and 0. So they ask for a sketch and not an accurate drawing. But this will help you because if I'm going to draw the vector ON, N will be somewhere here. N will be somewhere out here because it's 9 and 0. But this is not the accurate drawing, right? So the triangle will be O here, M there, and N there. And remember, M to L is 2 parts, and L to N is 1. So if this is split into 3 parts, let me see if I can make it into 3 equal parts here. How many centimeters? I'm not from 6. Okay, so this is 1, this is 2. I can't get to that, so let me just do this here. Let's say that's the part there. So we make it into 3 equal parts, and this is where L will be. L has to be because from M to L is 2 and from L to N is 1 according to the ratio. So this is the sketch, and this is what they all want. This is all the things they wanted in the sketch. So they said initially that OM is M and ON is N. This entire thing is N. From there to there is N. So If I wanted OL for ML, it will be 2/3 N, because this entire thing was split into 3 pieces. Okay, so now you want an expression from this triangle, right, in terms of M and N, the expression for M to N. So here, which one is the resultant vector? This is going in the same direction with that. So ON is the resultant vector. So ON is equal to OM plus MN. We know ON is N. Sorry, the N is not here. This is wrong. Forgive me. This is where ON is. This is where the N is. We got to find what MN is first before we can get what that is. My apologies. ON is N. OM is M plus MN. We take this over. MN is equal to N minus M. So this entire part here is N minus M. So if this part here from M to L is a fraction, it's 2/3 of M to L is 2/3 of M to N. So, and M to N is N minus M. So, M to L is 2/3 of N minus N. Hope you understand that. Let me go it again. This entire thing is M to N is N minus M. This N minus M was breaking up into 3 pieces, into 3 pieces. And this M to L is 2/3 of the entire thing. So M to L has to be 2/3 of M to N. Okay, and then you want M to L. M to L, we already did it over there. M to L, ML will be 2/3 of N that. M to L will be 2/3 of M to N, which is equal to that there. And finally, they want you to determine the position of the vector, of the coordinate, the position of the L, the coordinate of L. So I'm going to draw a Cartesian plane. So now we can draw these vectors. M to the vector M to L, M is 3 and 6, 3 and 6. So that's up here. The vector N is 9 and 0, 9 and 0, that's there. So this is the vector M, and this is the vector on the line itself. That's the vector ON or N. So we said earlier they want the position of L. L has to be somewhere. When you break this into 3 pieces, well, how would you know if the 3 pieces are equal? Well, you can't really determine that, so let's call this M, as we called it in the sketch, and N. So we know that L has to be somewhere here, and we also know that the vector M to L is 2/3 of M to N. We know that. So let's find Mn. Mn in this setting here, not the vector geometry part, we can find Mn by doing ending point minus starting point. 9, 0 minus 3 and 6. This will give me 6 and minus 6. So if ML is 2/3 of this, then it's 2/3 of 6 and minus 6. What does this become? 2/3 of times 6, 2/3 times minus 6. 3 goes into 3, 2 times 4, 3 goes into 3, 2 times. So this will end up being, end up being 4 and minus 4. This cancel with that, leave 2, 4 and minus 4. So I'm coming here now, ML is equal to 4 and minus 4. We know where m is, and this vector is ending point minus starting point equal to 4 and minus 4. Starting point is 3 and 6, 4 and minus 4, and that goes over. L is now equal to 4 and minus 4 plus 3 and 6. So 4 plus 3 is 7, minus 4 plus 6 is 2. We did this extensively in the previous videos. How to find the ending point of a vector, or how to find a point of a vector when you're given the starting point. How to find the ending point of a vector when you know what the vector is and you want to find the ending point and you have the starting point. This is one of the first videos we did. So the coordinate of L is 7 and 2. So that's the position. And I think that's 3 marks as well. So there you go.